Hey everybody, this is the corrections video for your factorization test. So I'm going to walk through each problem so that you know how to correct it, or if you just want to walk back through to kind of remind yourself before your quizzes this week. Number one is something that I did for you guys in class, so you should have it correct. But when you went into number one, what I reminded you was that if you have to find the lowest common multiple for two numbers, and one of them is small and the other one's larger, they're about 50% in difference, one of the things that might be easier to do is to take the larger number and just find the multiples of it. Now this one is pretty nice because 20, it's pretty easy to find the multiples of that. So you can also just go 2, 4, 6, and add a 0, 80. And then we talked about how you can stop after so many. These were easy, so I wrote out 5. If it was a harder number like we're going to get into below, where I'm actually having to do some work to find the multiples, I'm probably going to stop at that point. Now, number 9 on our multiple divisibility chart says that 9, you can tell if 9 goes into any number by adding the digits to see if they can be divided by 9. Okay, so for this one, I can add the digits. 2 plus 0 is a 2. 9 will not go into 2. 4 plus 0 is 4. 9 will not go into 4. 6 plus 0 is 6. 9's not going in. 8 plus 0 is 8. Nope, 9 will not go in. 9 plus 0 is 9, and winner, winner, chicken dinner. Okay? Same thing we're going to do here for 2 and 17. So for this one, I have a couple of choices. I can come over here on the side and I can just keep adding 17. Or I can say 17 times 1. 17 times 2, 17 times 3. Either way, I can get my multiples for 17. Because I'm also trying to match the multiples of 9, I am going to go ahead and get my multiples of 17 so I can just use my divisibility shortcut. So for 17, I can do the same thing here. Just going to continue to add. Okay, so I have 34. So again on these, I'm going to add my digits as I go. 1 plus 7 is 8. 9's not going to go into that. 1 plus 3 is 7. 9's not going to go into that. Now keep in mind that you can list these and just add them in your head. Alright, I'm just showing you. So I'm going to do those one at a time because I don't want to have to do this any more than I have to. So 7 and 4 is 11. It gives me 51. 5 plus 1 is 6. That's a nope. I keep going. I get 68. 8 plus 6 is 14. Another nope. So I just keep going. 8, 9, 10, 11, 12, 13, 14, 15. 85. So 8 plus 5. 8, 9, 10, 11, 12, 13. Nope. And it's 12. 102. 1 plus 0 plus 2 is 3, so no. And just notice that I'm adding these up as I go. 9, 10, 11. 9 does not go into 11, so that won't work. I'm going to check them as I go so I don't have to do as much work. 4 and 6 is 10. Alright, so as I continue, I hit 153. 1 plus 5 is 6, plus 3 is 9. Again, winner, winner, chicken dinner. Alright, so just be careful here because this is where you're going to make your mistake most of the time. Now, we got lucky again with the next problem because we have 9 going into 30. And 30 is also pretty easy to write multiples for. Remember that you can think of writing your 3's and just add a 0. So you've got 3 with a 0, 6, add your 0, 9, add your 0, 12. as your 0, okay? And same thing with the divisibility rules for 9. Now remember, this isn't for every number, it's just for 9s and 3s. Again, we add 3 plus 0 is 3, 9 will not go in it. 6 plus 0 is 6, will not go in. 9 plus 0 is 9, and there's your answer. Okay, for 7 and 4, a lot of times when numbers are this small, it's really going to be easier to just add them. But, you know, on a test, you want to make sure. So I've got 4, 8, 12, 16, 20, 24. Now I'm just going to go ahead to go to 7, so that will be 28, 7, 14, 21, 28. So, yep, this is a number that they have in common. All right, now this was your bonus, so number 5. And I did take this one off because it really would end up being a lot of work. And I will just tell you that the answer is 270. The most common mistakes that I found on this were that some of you had found 270 on both and didn't catch it. That's another reason why we take, do a few for 27, do a few for 30, and check. And then some of you had just started adding wrong as you ran out of room. So again, this was a bonus. Only a few of you got it, but it really would have been a lot of work, the old school way that we're doing it. Okay, so, all right, let's take a look. Continuing on. All right, 21 and 4. Now here's another situation where you have a bigger number and a smaller number. It's about 25% of what you got there. 20% really. So I'm going to recommend again that you do. We didn't do this already, did anyone know? So this is another one where, we're going to just start adding. Now 4 does not really have a shortcut. The best shortcut for 4 is that if your number gets bigger than 2 digits, you can just look at the last 2 digits. And if you can divide 4 into those 2 numbers, then the whole number can be divided by 4. So in this instance, what we're going to need to do is look at 4 into each of these numbers and do some division if we have to. So 4 times 5 is 20, so that's not going to work. Now when I look at this and I think, okay, 4 into 42, I can make some pretty quick choices just looking at the first number. 4 will go into 4 one time, and I'll have a 0. Then I bring down that 2, 4 will not go into 2. Okay, so you can look at some of these pretty quickly if you need to. Kind of like 63. Again, we can look at 4 into 63 pretty fast. 4 goes into 6 one time. I'll have 2 left over, and then it leaves me with 23. 4's not going to go into 23 evenly, so this is not going to work. I'm going to keep going. Now, when I get into a number like 84, again, I have to ask myself if 4 will go in this number evenly. Now, here's the thing. Both of these numbers, 8 and 4, are multiples of 4. So 4 will go into 8 evenly twice, and it'll go into itself one time. So, guess what? 4 goes into it evenly. That is your least common multiple. All right, and then same thing here. We're doing that again. 3 on the divisibility rules, it looks just like 9. So if I add the digits and they equal a multiple of 3, then 3 will go into the number evenly. So for this one, I'm going to start over here with 26. And I'm just going to start adding numbers. 2 plus 6 was 8. Nope. 5 and 2 is 7. Not a multiple of 3. Okay, keep adding. So just keep going until they give you the number you want. 7 plus 8 is 15. 3, 6, 9, 12, 15. 78 is your answer. All right. Now, on this next section, it just asks you to list factors for all the numbers. So remember that when you are looking through these factors, you need to check 1 through 10. Whoops, there we go. And we are using these divisibility rules. That is really dirty. Let me see if I have a cleaner one. We're using these divisibility rules to help us shortcut, okay? Because we don't want to take up a lot of time. What you're going to discover this week when we're reducing fractions is that there is a faster way that we can do this. So there may be some, why are you teaching it this way? But what I want is for you to be able to, number one, use these rules, practicing them, but also just to be able to think through for each number, what numbers would go in it? Can you pull them out? Because you'll need them for other things. So we always have 1 and 32. Okay. Next, we want to see if 2 will go into a number. Well, our divisibilities rules say that 2 will go in if the last digit is even, and it is. So you may be over here like 2 into 32 if you need to. You can break 32 into 30 plus 2, split those in half, right? And you'll end up with 16, whatever you need to do. All right, the rule for 3, again, add the digits, see if they equal a multiple of 3. So 32 is 3 plus 2 is 5, so 3 does not work. Again, when I get to 4, I'm going to have to walk through my 4s and ask myself, does 4 go into 32? Which it does 8 times. But you may have to write out the multiples of 4. Whatever you need to do to figure it out, do that. The rule for 5 says that the number has to end in 0 or 5. So 5 does not work. 6 says that if 2 and 3 go in, 6 will go in. Now 3 did not go in to 32, so we're not going to use 6. Okay, I don't have the divisibility rule for 7. So again, I have to look through and think through my 7s, even if I have to write out my multiples for 7 and make sure 7 doesn't go into 32, which, by the way, it doesn't. Then I have 8. If I'm checking for 9, I've got 3 plus 2 is 5, not a multiple of 9. And then my rule for 10 says the number has to end in 0. So my factors will be, and remember, we'll just go in this order. Make a U, 1, 2, 4, 8, 16, 32. All right, let's keep going with number 9, 94. Again, we'll just take a look here at our divisibility rules, starting with number 2. So I've got 1 and 94. If it ends in an even number, the last digit's even, then 2 goes in it. Okay, and don't forget, like we did up here, you may have to divide it or, break the number in half if you can't do it by itself. 90 and 4, whatever you need to do, that's going to be 14. All right, and then for number 3, we'll add the digits. 9 plus 4 is 13. That's not a multiple of 3. For 4, you just kind of do a little bit of mental math here. Will 4 go into it evenly? It's not going to. Right? 4 is not going to go into 14. It doesn't end in a 0 or a 5, so we're not going to use 5.
Let me get it, Blakey.
Number 6 says, the rule for 6 says it has to go into 2 and 3, which it does not, so there's no 6. That leads us to 7, and again, it is worth just checking to make sure you're not missing something. 7 times 3 is 21, so there's no 7. 8 is not going to work. If you look at 8 into 94, it goes in once. Then you have 8 into 14. Okay, here, not going to work. 9 times 10 is 90. and it doesn't end in a 0, so 10 doesn't work. So we just walk through those, and then our answer is 1, 2. Again, we just, in this order, least to greatest, 1, 2, 47, and 94. Alright, so remember to compare these with what you have, so you're kind of looking at where you went wrong and why you didn't get all of the numbers. Now, for number 10, this one I've seen a lot of mistakes on, and it's actually a simple answer, but if you are missing any numbers, it is because you did not go all the way through numbers 1 through 10, okay? So we kind of just use these rules to walk through. You know, if 2 works, it would end in an even number. It doesn't. If 3 works, we can add the numbers. 4 plus 9, that equals 13, so that's not a multiple of 3. 4 goes into itself evenly, but it's not going to go into 9 evenly, so that's not going to work. It doesn't end in a 0 or 5, so 5 doesn't work. 6 says if it can be divided by 2 and 3, 6 works, and that's not happening. And then we go to 7. Now for some of these, you're going to have to check. My suggestion to you would be, like, if you're looking at a number like 49, start thinking to yourself, okay, well, what's 7 times 5? Like, try to think of any facts that you know off the top of your head. What's 7 times 9? Things like that. And that way, at least, like, you're starting at 35, right? Then we can add 7 and, you know, keep going until we get near 49 to eventually realize that 7 times 7 is 49. 8's not going to work because it's the next number. 9 will not work because 9 times 5 is 45, and then it does not end in a 0, so 10 is out. So our answer here would be, again, just in this order, bloop, 1, 7. Remember, we're only going to list that one time, and 49. Okay. Next page, number 11. And we go to 53. So guys, I mean, it's the same. It's the same. Again, this week or whenever everybody gets back from being sick, you know, we will be solving this with prime factorization. But until then, you need to be able to dig through each of these numbers and find factors. It's going to help you longer down the road. So, alright, so we just go down our list again. The last number is even. 2 works, so there's no 2 here. If 3 works, then I should be able to add these. 5 plus 3 is 8. 8 is not a multiple of 3, so 3 is out. Okay, then I look at it again, and you'll get to where you can kind of like see this in your head, but 4 is going to go into 5 one time. When I subtract, it'll be 4 into 13. Does not work. Doesn't end in a 0 or 5, so 5 doesn't work. 6 is not going to work because 2 and 3 didn't. 7 times 7 was 49, we just discovered, so that's not going to work. Same thing with 8. You know, again, for 8, if you have to start writing out your multiples, then that's what you have to do. I am going to throw out that 8 times 7 is 56, so I'm going to call that one. We also said that 9 times 5 was 45. 45 plus 9 would be 54. And then, so that doesn't work. And then it doesn't end in a 0, so 10 does not work. That means, guys, that this one was prime. Okay, it only has the 2 factors. And we'll do this one last time with 50. Now, 0, when we look at for number 2, last number being even, 0 counts as an even number, okay? 10 we can split right down the middle. So I'm going to say 2 times 25. 5 plus 0 is 5, so 3 does not work. 4 goes into 5 one time, with 1 left over. 4 does not go into 10 evenly. It ends in a 0 or 5, so 5 works. That's going to be 5 times 10. 2 and 3 didn't work, so 6 doesn't work. We said that 7 times 7 is 49, so there's no 7. 8 times 5 was 40. 8 times 6 is 48, so 8 doesn't work. And we already have 10 here, so 9 does not work, and we are done. Make sure that you are writing your facts out. Again, least to greatest. And these are all your facts. Factors, sorry. Okay, now for this one, we're going to break it up a little, and we're looking for prime factors. So remember, when you are looking at these digits, you can start with any numbers you want, and you're going to get the same answer. When your number is even, the easiest thing that you can do is start with 2. But again, it's totally up to you. When you use your divisibility rules, it's really easy for you to run through and find some numbers that you can put into it. For instance, 2, we'll go into it because it ends in an even number. 4 plus 8 is 12. 12 is a multiple of 3, so 3 works. You can divide 4 into this number. 4 goes into itself once and into 8 twice. So again, lots of choices, okay? Lots and lots of choices. I'm going to go ahead and just start you out by 2. Remember that your prime numbers, and you'll start memorizing these, 2, 3, 5, 7. You're going to go ahead and circle those. Half of 48 would be 24. Alright, so we just keep breaking these down any means necessary. Okay, I'm going to do 4 times 6. It really doesn't matter. One of the big mistakes that I am seeing you guys make is that instead of multiplying here, like especially for 6, see it a lot. I'm seeing 3 and 3. Like 3 plus 3 is 6. So make sure that you're thinking multiplication. Add that multiplication sign when you need to. Oh, and this was not prime, my bad. So that'll be 4. Okay, so now once you have broken everything down to prime factors, we've got 1, 2, 3, 4 2s. So in my answer, I'm going to go 2 times 2 times 2 times 2, and then I'm left with a 3. And I'm just going to go back and count to make sure I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I've also noticed quite a few of you who are maybe putting in 3 2s instead of 4, maybe putting in an extra 1. Just double check, okay? And just take your time. All right, I'm going to come over here and build out my 60. Again, it's even. 2 goes in it. 3 goes into 6. 3 works. 4 works. I'm looking at it. 5. 6 works. 7 doesn't. 8 doesn't. 9, and then 10 works. So you have lots of choices here, but again, we can just break it down into 2s. 30, I'm going to do 3 and 10. Okay, and then I just keep going until I only have numbers that are prime. Now I'm going to go through all of my prime numbers and put them in order least to greatest. So I've got a 2 and a 2, a 3, and a 5. Take your time, make sure you're copying them correctly. Alright, 27. I look at these divisibility rules. Let me pull this up here. The last digit's not even. 2 plus 7 is 9, so 3 works. So we could do 3, and that's 9. 3 is prime. 9 is 3 times 3. Prime, prime, and you're done. So your answer is 3 times 3 times 3. Okay. Alright. Almost done. And remember, if you are confused about any of these, just, write them down, put a question mark next to them, and bring them, and ask me to walk you through them. Okay, we're still doing prime factorization. Again, you can reference here. We're not ending in an even number. 3 plus 5 is 8, so 3 doesn't work. 4 times 8 is 32, so 4 doesn't work. 5 does work, so I'm going to do 5 and 7, which, by the way, are both prime. So your answer is 5 times 7. Done. All right, 24. Again, we're even, so we can just start with 2 and 12. I can break 12 down into 2 and 6. And then remember on this, multiplying 2 times 3. Alright, so that's 1, 2, 3 2's. That's 2 times 2 and times 3. And there's your answer. Okay. The last thing that we had here was greatest common factor for a number. So I have 2 different numbers. You need to know the factors of, and then we'll figure out which ones they share, and then just the biggest one wins. Now, one thing I've asked you to do over and over is to check, will the smaller number go into the larger number? So, if I'm looking at 32 and 64, I mean, they're pretty close. So I'm just going to do a quick check here, and what do you know? 32 does go into 64. That means that 2 times 32 equals 64. So guys, your GCF here is 32, and that one's done. Okay, so definitely check it. Now I'm looking at 12 into 20. 12 does not go into 20. 12 times 2 is 24. So for this one, I'm going to need to kind of break these down. All right, got 1 at 20, 2 and 10, 3, 4 and 5. I'm just going to kind of walk through them. 6, 7, 8, and we're pretty much done there. Got our 10. Okay, and then I've got 1 and 12, 2 and 6, 3 and 4. So if I list these, go least to greatest. So I've got 1, 2, 4, 5, 10, 20. Okay, and I'm going to compare that to my factors of 12. 1, 2, 3, 4, 6, 12. Now I just need to find the numbers that are shared. Okay, both have a 2. We both have a 4. 5, 10, 20. So the greatest common factor that they share is a 4. Alright, and then we have 18 and 24. So we'll just, again, I'm going to use my rules of divisibility to walk through the numbers and make sure I write them all down. Alright, 2 and 9, 3 and 6, 4, 5, 6, and we're done. Alright, 1 and 24, 2 and 12, plus 4, 3 and 8, 9, 10, and we're done. Okay, same thing. So again, I've got 1, 2, 3, and I'm just copying these down, least to greatest. 6, 9, 18, and we're comparing that to, again, least to greatest, 1, 2, 3, 8, 12, 24. Alright, so we share 1, 2, and 3. 6, 8, 9, 12, nothing else is shared. And the greatest of these common factors is 3. By the way, you do not have to line them up like this. Okay, you could have done that from here as well, right? Totally up to you. You say, oh, we both have a 1, both have a 2, both have a 3. I'm just trying to show it to you across the board. Alright, again, if you don't understand how we got any of our answers, bring your paper to class and ask me. And these are going to be due on Wednesday. All right, bye, sweeties.